Welcome back to the part 2 of this series. Now it's time to get some hands-on. So in this video, we will install RTF as an appliance on Amazon Web Service. So to create a Runtime Fabric instance, log into your Anypoint platform account, open Runtime Manager, and then click on Runtime Fabric. Once you open RTF console, you can see the list of all the instances. Right now I have only one instance which is in disconnected state. Let's create a new runtime fabric instance. Now let's fill up all the required details. I'll name it as VP demo RTF. Then in the install on option, last time we created EKS. Now we'll create VM on bare metal because we want to explore the appliance model. So in this case, as you already know, we do not provide Docker and Kubernetes on our own. We just provide bare metal or VMs. MuleSoft will install Docker and Kubernetes based on the appliance. So basically, they'll be using Gravity to install that. Select VM or bare metal, click on Next, and the RTF instance has been created now. So we see that it's ready for activation. Uh, the version, ownership, and distribution is appliance. Now we can download the files for installation. So let's just download and let's explore what is the content in the file. All right, so here's the extracted file. Inside, if you see, there are multiple folders: AWS, Azure, manual, scripts. Now, why do we have AWS and Azure? See, in AWS and Azure, you can have a dedicated Kubernetes cluster, which they provide. But alternatively, you can also host plain virtual machines, right? So in that case, if you happen to host the virtual machines on AWS, you can use the scripts. If you happen to host on Azure, you can use this. In case if you are not using any cloud provider service and just giving bare metal hardware, you can use manual. For example, I have two laptops. I'm just opening them to the internet, and I want MuleSoft to create cluster on these two laptops. So I can manually configure this by using this manual folder. Alternatively, if even if you are on AWS and Azure, eventually it's a virtual machine, right? So you can still use this manual folder and the scripts. Okay. Now this AWS and Azure folder basically have the Terraform scripts, which can be used to just get all the environment created, like spinning up a virtual machine, depending on how many node cluster you want, configuring the network, and everything. This can be done by the Terraform scripts, but we'll not be looking into this because it basically hides everything from you. You won't be able to understand what's going on. Because as you might remember in the EKS video that I've created, we used EKS command. It created everything. We could not get what actually happened under the hood, right? So in this video, we'll be hosting our virtual machines on AWS, but we won't be using the scripts. Rather, we would be using this manual folder, generate config, and then finally the scripts. Now, what's the difference between scripts and this manual folder? So this manual folder basically has generate configs. So it is a shell script which will create configuration for you. So it will output some detail, and based on that you can create files. And this file would nothing but the details of nodes, what is the IP address of node, which mount, where have you mounted your Docker device, HCD device, and all those sort of things. We'll explore this file. And in script, basically, this is the script which does all the heavy duty work, which is configuring the Kubernetes cluster, formatting the disk for installing Docker and all Kubernetes components, and configuring the container network interface, and all those heavy work is done by this init script. So let's explore these two files and let's see what is there inside it. So here's the generate config shell script. This script essentially helps us in creating environment files. So all the nodes in the cluster will have environment files, which will have all of this details which are required by the init shell script. So these details are basically RTF controller IPs, RTF worker IPs, and RTF activation data. So these are the requirement values. Other values are also there, but those are optional. Optional because it doesn't mean they are not at all required. They are required, but there are default assigned to it. In case if the values are different than default, you have to explicitly specify. Otherwise, it will fail to install. So what is the RTF controller IPs? So as the name suggests, it is the IP address of all the nodes who will behave as controller. Now please make sure that this IP addresses should only be private IPs and not public IPs. And also all the private IPs of the nodes need to be static. RTF worker IPs, it's quite similar to controller. It's just that the private IPs of nodes behaving as worker. Activation data, we saw it just now. When we create the RTF instance, we get an RTF activation data. We need to paste it here. Now, couple of important properties from environment variable. So RTF Docker device and HCD device. So we need this two additional components. So when we will create virtual machines on AWS, we will also mount few disk drives on those VMs, basically for HCD and Docker. And now, if you are familiar with Kubernetes terminology, HCD is a control plane component of Kubernetes. So this HCD device would be needed only in case of the controller nodes. Docker device, it's to install Docker. So this would be Docker device would be needed in both controller and the worker node. So whatever is the mount point, we have to specify it over here. If it matches with this, you don't need to modify. Then is the mule license. So it's optional. If you provide, well and good. If you do not, there's no issue. Installation will succeed. Only thing is that you won't be able to deploy your application. And if you want to deploy app, you have to manually install the license at later point of time. Now, in case if your nodes are behind some proxy, they cannot access the internet directly, but can access only via proxy. You can configure all these values. But in this case, we'll keep things simple. All the nodes will have direct access to the internet. Basically, I'll attach an internet gateway to the VPC that will create in AWS. Then the pod network CIDR. So pods will have their own network, right? So they should have a CIDR range. So if you define, it's well and good. Otherwise, it will pick up default values. Same is for service CIDR. So let's see what uh, happens here. So if you observe this, these are the values that will be picked up. So you need to copy this three also and paste it here with the actual values. We'll see those later on. But if you observe pod network CIDR, it's getting a default network 10.22.44.0 with a mask of 16. Similarly, service CIDR is having a network mask of 16 but on a different network. So all these values will be taken if you do not provide, but these three values you have to provide and paste it here. So these are the values that it will take, and it's also specifying the install DR. So it will create this folder OPT Anypoint runtime fabric. And then you have three condition. The first one is the very first node on which you'll install, right? So it will be the controller node and it will be the leader because it's very first node in the cluster. So for that, it will output some code with all these values. Then once the leader is created, you might have other controller nodes, but they won't be leader, they would be joiner. So if you see the install role is joiner, so you'll get a file for that as well. And finally, you'll get something for worker. So if you see in worker, you just have Docker device There's no etcd device as such. And also the activation data, it's required only on the first node. So if you see, the activation data is present here only, on others you don't see. So depending upon the number of IPs for the controller that you specify and the number of IPs that you specify for worker, it will basically output this data and just create a text. In that text you'll be only have this uh, it will have commands to create that directory that we just saw, and in that you'll have for each node you'll have the required configurations. So once you get this, you copy the content based on the node and you paste it on the respective nodes. We'll see this when we configure, we'll see how it works. Then the next file is init.sh. This is the main file that does all the task. Its job is to fetch the configuration, read it, and accordingly install or set up the whole runtime fabric onto the nodes and create a cluster. So basically, this script has multiple functions in it, which it will execute. So if you observe, here are the steps that it checks system parameters, installs required packages, formats and mount disks. So the disk that we discussed, it will format and mount them, configure IP table rules, enable and configure kernel modules. So all these steps will be performed by these scripts, and the best part is, if any of the step fails, it will automatically continue from there. Or if you want to manually execute a particular step on your own, you can easily specify the name of the script and just specify the name of function, and it will automatically do the task for you. So I'll not be able to go through all of this function one by one, but let's discuss a couple of important functions. So first thing is that you always need to be logged in as a root user, because if you see, this check root user will ensure that if you're root or not. If you're not, the installation will fail. Then other important thing is that you observe the console, which is for Ops Center. So one good thing about this appliance model is that you get the operations center, which we have already discussed in previous video, wherein you can monitor the RTF cluster. You can get a view of logs, a view of the metrics, the amount of memory, CPU utilization, and all those metrics in the form of graph you can get in the Ops Center. So basically, this step will create an Ops Center URL and give you a set of credential, that is the username and password, which is this is their default username, and it will dynamically generate the password. So you need to use this for the first login, and then you can add multiple user on that console. So that's all. And the other one is activate. So in case if you do not provide the activation data, it will throw this error, activation data missing. Alternatively, you can manually run this script, a particular function. So this is how you run .init.sh, call the function. The function name is activate, and give the activation data. So similarly, if you want to call a specific function, you can just give the name of the script, function name, and whatever input it requires. So we won't be changing anything in this file. This file remains as is. The only modification we do is to this file with the values that we have. It gives us the environment values. We create an environment file, and then the init.sh will leverage those environment value file and set up the cluster for us. So that's all about this two important file. So now let's work on the infrastructure setup part. I'll be using AWS for this demo, but you can use any cloud provider of your choice, or you can also consider using physical machines or virtualize a few VM on your laptop, provided that it has the required amount of RAM and disk space. So let's spin up EC2 instances, but let's see which images we would need and what type of machines that is required to launch this instance. All right. So To spin up any machine, if you go by the default mechanism, AWS will directly allocate its own version of Linux. But that's not what is required. We want a specific version of Linux. So on the left corner, you see in images, you see AMIs. Click on AMIs, and in public image, you can search the AMI. So which AMI do we need? We need Red Hat Enterprise Linux. So you just copy this. I'll paste it in the comments description section, and I'll also let you know from where did I get this machine ID. So just search it. So if you search, you get this image. Once you click, you can launch instance from this AMI. Now remember, this machine image is not free. It comes with a cost, and we'll discuss what are the charges for this AMI. Now the question arises, from where did I get this AMI? So let's find that out. So if you go back to the folder that we just extracted, in that you have AWS. So inside AWS there are a couple of files. So these are the env files that we have just saw how seen how to create those. But what you should look at is the fabric.tf. So this is a Terraform file which has all the values that the script will use to create or set up the infrastructure. So let's open this file. So if you observe this file, it has all the required variables. So we are not going by this mode, but we can fetch values from it, right? So if you just run this Terraform file, it will give you an infrastructure. It will provision an infrastructure with one controller and two worker, which is the minimum requirement. What we are interested right now is the AMI name. So this is where you can get the AMI that has to be used. And there's a possibility you can choose other AMI, but this one is tested and it works well. So you can consider using this, or else you can do hit and trial. But again, if you are doing on a personal account, that would incur cost. So if it's from learning perspective, you can just right away use this AMI name. Also, for setting up controller and worker, you can choose M5 large instance of EC2 instance, and for worker, you can choose R5 large. Now you can also play around with it, but the only thing is that if you spin up worker with this machine image, the problem is that this is charged on an hourly base. So even if you spin it up for 5 minutes and turn it off, you will be charged for that license image plus the amount for spinning up at EC2 instance. So if it is a micro instance, then it's fine, it's free of cost. But if it's any other instance with this paid image, you will be charged for it. So it's better to use the same image that is recommended here, and the controller and the worker node of the same type. Where we can save our consumption is we'll try to use a low quality disk drive, which will not be an IO one, but will use the general purpose. Because if you go by Terraform script, it assigns you an IO device which charges you based on the IO. So this is the file you can always refer and see what all are the details it uses. But now we are going to do this all of these steps manually so that we understand what's really going on. So now let's click on launch instance. So it will not launch, but it will ask you a couple of details. So let's see what details it asks us. All right, so this is what appears when we click on the button, and it asks for few other details. So first thing, by default, it will select the free tier eligible. If you are a free tier customer, which I am right now, in that case, it will give you a T2 micro instance for a certain period of time within the free tier limit. But we don't want this. Even if you try to use this with this image, you will be charged for that image, but not for this instance. But the installation will fail because it doesn't have the required capability. So what minimum you have to use is at least M5 for controller which is 2V CPU and 8 gigs of RAM, and R5 for worker because worker will have uh, the load, right? So it has to use 16 gigs of memory. So M5 and R5, and you need to have at least three nodes so that you can successfully deploy at least one application. With one worker and one controller, you cannot deploy a single app. You can get the cluster running, but you cannot deploy. So you need to have at least two workers and one controller to deploy a single app. So now, apart from this, you would also want to give a default storage. Now, this is not the mounted storage, but the storage that the VM comes. So ensure that you at least choose 20 to 30 GB of storage. For a safer side, use 30 GB because if you use 10 GB, again the installation will fail. And with free tier, you get around 30 GB of storage free for each month, I believe. So unless and until you exceed that 30 GB of range, right? So you won't be charged. But if you exceed that 30 GB of storage, you will be charged accordingly. So let's check how much charge we would have to pay. Now, despite this being a free tier, we will end up paying some amount, right? So let's understand how much this demo would cost you. And make sure that once you finish the demo, stop the instances, otherwise you will have to pay a good amount in the form of bills. So the cost of this AMI is $0.6 per hour. Now, if you add to that M5 large instance, which is charged $0.101 per hour, add the image cost, it becomes 0.161, which is around 13.5 rupees per hour when dollar to INR conversion is 81.6. So controller node is not that expensive, but the worker is slightly. So it's $15.52 per hour multiplied by 2 because you would need two instances. So it turns out to be 31.3. Add both of them, it becomes 44.8. Now this is the minimum charge. You won't be running it for 1 hour. Of course, you might encounter some issue and something. So at least minimum you can consider you will spending around 3 to 4 hours and multiply this by that amount. So I think if you try to work out this demo, you'll easily end up paying 500 to 600 rupees. And do not forget the device storage. If you exceed that limit of 30 GB, which of course you are going to, it will add some amount to it, but it's not that expensive as compared to this uh, image instances. So I hope this gives you a clear idea of how much you would end up paying. And just remember, every time you finish with the demo, it's always good idea to stop. Do not uh, delete those instances, but just stop those instances so that next time when you can easily start and the cluster will be in place. Okay. The only thing when you stop, the only thing that you will be charged is for device storage, but you can't do much about it. If you delete this device storage, then you'll have to set up the cluster from scratch. So I hope this gives you a fair idea of how much charges you'll have to pay while performing this demo. All right, so now let's move back to the launch instance page, and we have a couple of things already configured. We can give the name to this node or the VM. We can select the instance type. For controller, we'll be selecting M5 large. But apart from that, there are a couple of few configurations that needs to be done beforehand. One is the key pair login. So to SSH into the VM instance, we would need a key pair. So we'll have to create that. Before that, we have to do some settings for the network. Now in network, let's edit this. And inside, if you observe, there is a VPC required. Right now, I do not have any VPC, so I'll need to set up a VPC. Again, we need to select a subnet, create a subnet and then assign it. And ensure that you assign a public IP, set it as enable, because if you do not set it as enable, the default value is disable. It won't get a public IP and you won't be able to access this node via putty. You'll have to then eventually end up creating a VPN from your network to your AWS network, which is very tricky task. So ensure that you and use the enable, otherwise you'll have to stop the instance and create a new instance altogether, and that would eventually cause you to pay the amount for 1 hour which you haven't even utilized. All right, so let's first create VPC. So in the search, you can search for VPC. Let's open this new tab. Now here, click on VPCs and let's create a VPC. Now let me name this as VP RTF Appliance VPC. Okay, I'll use IPv4 CIDR block, and I think the default 110 with subnet mask of 24 is enough. It's just demo, so that should be enough for us. I'm not using IPv6, so let it be no. And we can use tags basically to identify all the resources being consumed. So that should be enough. We will get private IPs in the range within this CIDR block, starting from 10.0.0. So let's create this VPC. Okay, so the VPC is now available. Now this VPC will be isolated. Any node being deployed to this VPC will not have internet access. So to get that internet access, we need to create an internet gateway and attach it to this VPC. So let's click on internet gateways, create internet gateway, and name this as VP RTF Appliance IGW. Okay, and let's create this internet gateway. All right. So the gateway is created and the state is detached. What we need to do is attach it. So let's attach to a VPC, and here is the VPC. Click on attach. So if you do not attach an internet gateway, it's simple. Your VMs won't be able to talk to the MuleSoft control plane, and the installation won't at all happen. So that's done. We have the VPC ready. We have the internet gateway ready. So if you go back to this launch instance and refresh this, we are able to see the VPC gateway. Now you can also choose to have subnet. So subnet would basically create inside a VPC, it will create a subnet. So let's create a subnet also. Okay, so let's choose this VPC. Now subnet, I'll just add the whole VPC into one single subnet. So, but you have the flexibility, like if you want to keep the controllers in one particular subnet and workers in one particular subnet, or maybe you have a bigger VPC and inside you, apart from this RTF instance, you have some other instance. In that case also you can use subnet. So subnet is basically isolating network. So the bigger isolation is VPC, which is isolating from the bigger cloud. From VPC, again, if you want to have isolation in your own personal network, you can use subnet. For example, there could be some applications that are very chatty. They do a lot of communication. So having them in the same VPC would add to congestion of the network. So instead, what you can do is you can move that chatty applications to another subnet and let them chat among each other and send messages. It doesn't affect our network, right? So right now, I don't have such requirement, but just I'll add a subnet with the default CIDR value, which is that of the VPC. Let's give this name VPRTF subnet, and availability zone, I'll keep it as no preference. Use the CIDR block, and let's create the subnet. Okay, so the subnet is now ready. Let's go back to the launch instance. Let's refresh this, and the subnet is selected. Okay. Auto assign public IP. Let's enable this. Now security groups. So it will create a new security group. If you have any existing one, you can select on existing, but if you do not, you can create a new one. So if you select this, it automatically gives the name and all these details. So what I would do is I would create my own custom security group. So VPRTF security group. Right now, description, you can give any description. SG for RTF. Okay, so the basic thing what we want is to SSH. So protocol is TCP and port range is 22, which is fine. And if you give anywhere, which means that it will use a subnet mask of 0, you can access from the internet or anything. And it's also saying that rules with, it's just giving you a warning. You can either choose to go with the default ones or else you can add specific. So if you want what security groups you need to add in detail, you can refer this article and it lists down all the port that needs to be opened. Otherwise, for demo purpose, what you can do is let's add a couple of rules. So source anywhere and let's try to edit this. Okay, let's add security group rule. Or instead, what we can do is let's create a new security group. So let's search for security groups, this EC2 feature. Okay, so the default security group is created. We can rather choose to create a new one. Okay, so VP RTF security group. Let's give this name. It selects the VPC on which it has to be applied. So by default, we had one right now, so it's selected. Otherwise, you can choose from the drop down if you have multiple. So there are inbound rules and outbound rules. So inbound is for incoming traffic, outbound is for traffic which is going outside. So the outbound rules you can configure based on this list. Otherwise, you can, if you want to give an open access to the internet, you can basically allow all traffic. That should be fine. Depends upon your need, but for demo purpose, that should be fine. Now let's configure inbound rules. So for inbound rules, what we will do is we'll allow, first of all, we need SSH. So let's allow SSH from anywhere on the internet and description SSH access from internet. Okay, and let's add another rule. And in this case, we need to allow HTTP and HTTPS traffic. So again, we can use those rules. HTTP on port 80, allow it from anywhere. HTTP from internet. Then let's allow HTTPS as well. And let's allow it from anywhere. Now, if you have if you have static public IPs, you can also specify those. Right now, I don't, so I'll use anywhere. HTTPS from internet. All right. And one more rule is that we should allow traffic from the internal network also. So in VPC, right, we have a subnet. So any applications or any VM which are present in this VPC or that, because VPC and subnet have the same CIDR block, so we can assume VPC and subnet are the same right now in our case. So if two machines in the same VPC wants to communicate each other, that traffic also should be allowed. So what we can do is we'll use all traffic. At least inside a cluster, we want all TCP connections from, okay, not from my IP, but custom. So in custom, what we can do is we can uh, give the prefix. I don't see it in the list, but rather I know the CIDR block, right? 10.0.24. Okay. So this is the CIDR block where I want to allow all the TCP traffic coming. So I'll say this is for internal access so that worker node and controller node can talk to each other. So all these rules should be enough. But if you don't want to manually add, you just allow all TCP from anywhere, and in that case, it can serve the purpose. So with this setup, let's add a description to this whole security group. Allow access to RTF, and let's just save this tag name VP RTF security. Oops. Okay. With all these details in place, let's create the security group. All right, so security group is created. We have the inbound rules that we defined and the outbound rules. Basically, outbound is allowing all the traffic. All right, so the security group is ready, and now we should be able to see the security group. So let me select from existing. If I'm able to see this, right? Select this, and that should be good enough. So we have created VPC, we have created subnet, we also assigned an internet gateway, and we have enabled public IP. Now storage, make sure that you give generous amount of storage, at least more than 20 GB. I would suggest give 30 GB so that the installation doesn't fail. What happens is when it does all the installation, and if it finds that the space in the temp folder is less than 5 GB, it will fail the installation. So make sure that you give at least 30 gigs of space. 20 might also work, might not work, but the problem is that if you're using your personal account, you cannot afford to make mistake, because any mistake will just cost you 1 hour of billing, wherein you eventually end up doing nothing, just wasting the credit, right? So for that reason, uh, if it's a corporate account, yeah, you have the freedom to do trial and error. There, you don't pay it, but the corporate will pay it. All right. So one last thing that we need to do is create a key pair. So let's create a key pair. Right now, I think I don't have any, right? So let me create a new key pair. Let me name this as VP RTF Sydney. I'm using Sydney region, so let me give this name key pair. All right. So I want to use putty, so I'll use .ppk, and this should be fine. Let's create this key pair, download a key pair, and I'll have to use this while logging in using putty. Okay. Now the instance type. Let me select m5.large. All right. So I've selected m5.large, and you would see that pricing changes depending on the region you are. So right now it's 0.12 US dollars per hour, but in some other region it might be less expensive. Okay, so let me give this name VP hyphen controller controller node. I'll only be using one controller node, so I'm not giving it any number, but VP controller node. Let me add RTF also. That's the convention I decided to go with. Okay, I think I have pretty much everything ready. M5 large, key pair is selected, security group is selected, and assign public IP is also done. So storage is also done. Don't need to configure any advanced detail. That's beyond the scope. So now let's quickly create this instance. So let's launch this instance. It should be up. Okay, it says that it has initiated. Let's click on this and let's see what's the status. Okay, the instance is up and running. Now it has a public IP address, it has a public private IP address. So this is what we need to keep in mind, and we'll be using in that environment script, right? Well, the configuration shell script that we saw. So we'll use this. And this is the public IP address. So we have the server up and running. Now let's move on to the next. All right. So now we need to create a couple of config files so that the init script can use. So to create that config file, we just need to edit this and let's see what output it gives. So what I've added is I've added the controller and the worker IP. Controller I'll have only one, and worker IPs I do not have it right now, but just so that we get an idea how the file is created, I have just added 80 and 81. We can edit this files at later point of time. We'll also have to give the Docker device and etcd device, which we will do in a couple of minutes. We haven't added to the controller node that we created, but we can again edit this later point of time. So all the details are given. I've also added the activation data. Make sure that you add the license key as well. And then all you have to do is just run the script. So if you're on Windows, you can use git bash, and inside git bash, all you have to do is locate that folder wherein you have that shell script and then run generate-config.sh. If I hit enter, what do we observe? So it's giving us instructions. It's saying create this folder, copy each snippet. So basically what this snippet will do is it will create a file name as env inside this folder, opt anypoint runtime fabric, and it will add all these values. Now you can either use this script or you can manually create that file and add all these values. It's up to you. This script just gives you all the required files. So it created for the uh, controller node, it created for the worker node, and it then edits this, right? So if it is a controller node, node role is controller, and since this was first controller node, it made it as leader. Had this been a second controller, it would have made this as joiner and node role would be controller. On the worker, it's just worker node, role is joiner, and you only have Docker device, no etcd device. And similar is for the second worker. So that's it. There's nothing much in it. You can also choose to do this manually. Copy this content, create a file, and write this content or paste the file on your respective nodes. All right. So now let's log into the node and create this particular file. Okay. So let's open Putty and I'll log into the server, but I need to add the key. So I'll go to auth, select the key. It's in my downloads. Let's use this key. Open. And now let me go back to session. I need to enter the host name. So I'll get it from here. I need to use this public IP address. Let's copy this and click on open. It's taking time. Okay, so The connection has failed. Now, let's try to find out what went wrong. Most likely, there's some problem with the configuration. So, let's go back. And if we observe in the VPC section, we have something called as root table. So, we need to edit this root table. Let's go to the root table. And right now, all that we have is that access from the local CIDR block. Let's add one more rule. Let's edit this. Add root access from anywhere. It has to go through the internet gateway, which is this. Save changes. And now we should be able to access. Let's restart this session. Now it's able to access. Let's accept. Login as EC2-user. Okay, now I have to again add that auth mechanism, the PPK file. Let's quickly do that. All right, so I've now logged in, and what I would have to do is copy this contents and create and just run this script. Sometimes what happens is whenever we copy this content and run the script, the file isn't the way we want. There comes additional spaces. So what you would rather do is just copy this, create the env file on your system, and then use scp to paste the file in that particular location. So before that, let's first create this folder, runtime fabric. So let's log in as a root user. So sudo -i. Now I'm logged in as root user. Let's check the present working directory. So it's root. Let's do a cd ls. Okay. Now let me create mkdir. I need to create opt. So I think opt is already there. So let me cd in opt ls. There's nothing in it. So let me create. I'll create Anypoint folder. Then I'll create runtime fabric. And finally, inside this, we'll have the env file. So cd runtime fabric. Now we can either create here the file directly, or instead let's create this file on notepad and use WinSCP to move that file. Okay, so let's open notepad, create a new file. This document, let me name this as env. All right, now time to copy all of this content. It's copied. Let's open this file, paste all of this content, and we'll basically remove all of the spaces. All right, so I've removed all the spaces. Now file, save as. So let me save as without any extension. So env, just save it. Yes, so it got saved. Now all I have to do is just move this file to the server. So let's open WinSCP. So now in WinSCP, let's log in. But now we don't use username and password. We rather use a key. So let's go to advanced. Click on SSH authentication. Select the PPK file that we just downloaded. This is one. Click on open. Click OK. And let's log in. Click yes. Now to do this task, you can basically also use Linux command, but I don't like this black and white screen, so I'm doing via these tools. You can also like use the Vim VI editor or use the touch command to create file and or basically even use this command. The only problem is that sometimes the indentation goes wrong and the installation fails. So for those reasons, I'm basically using Windows machine and creating all these files, and I'll just paste it here. So now let me go to root. Let me just navigate to that path, which is OPT. So here's the folder, runtime fabric. Okay. So now I have to paste it in here. Okay. I think there's a mistake here. This runtime fabric should have been inside the Anypoint folder. So let's fix this. So let's delete this rmrf runtime fabric. S- Okay, let's cd into Anypoint and mkdir runtime fabric. Okay, so we have the folder now. Let's refresh. Inside Anypoint runtime fabric. Time to paste this file. Okay, permission denied, so I'll have to change the permission. So I've in Putty, I am logged in as root user, and in WinSCP, I'm logged in as uh, EC2 user. So I need to give permission to this folder. So I'll use chmod, and what is that command? So I'll use chmod. I think it's 777, and the folder name is runtime fabric. And this time I should be able to paste the file. Let's copy this. Yes, it got pasted. Now again, let me change the permission for this file. So let's click on properties because this has been pushed by uh, the EC2 user, right? So let's give all the permissions. Execute 777. Okay, so now root user can also access because it's the root user that will run the init scripts. So all right, so let's see if the file has is visible to this root user as well. So cd runtime fabric. Now, if you're good at Linux, you don't even need to use WinSCP. It's just that I previously had a bad time working with this touch command and Vim command, so I preferred this mechanism. You can choose your own, whatever works for you. So let's check this file if okay. So it has all the required contents. All right. Now that we have, now we would also have to edit this file again because we haven't mounted the etcd and the Docker drive, right? So let's quickly mount those two drives. All right, so now let's attach some volumes to our controller node. So right now, if we check storage, we just have only one default volume, which is having size of 30 GB. We need to add two more, which is for one is for etcd and one is for Docker. So 20 GB of storage should be enough. So let's add those. So to do that, you need to click on volume. But before that, ensure that you check the availability zone. So it's AP Southeast 2C. So volumes also should be allocated in the same zone. If it is in the different zone, it cannot be attached to this instance. So with that in mind, uh, let's add those new volume. So click on volumes and let's create a volume. So a general purpose SSD should be fine, but if you go with the Terraform script, it for etcd it will use the provisioned IOPS IO2, which is quite expensive. So for our purpose, general purpose SSD is fine. But if it's from a production point of view, it's always important that you use provisioned IOPS IO2 because it has good amount of read write speed, especially at CD needs that. For demo purpose, this should be fine. 20 gigs of size is enough. Uh, and availability zone, we saw that it was 2C. So let's use that. And I don't want to create it from snapshot. Let's add tag name PPRTF Appliance. These tags are optional, but you can give if you would just want to search resources by tags. All right, so now let's create this volume. So it's creating. Let's create another volume, and this one again, let's use this as 20 GB 2C, and let's add tag Lions. This one I'll use for Docker. Create volume. Okay, now I have all the volumes ready. The latest one is being created, but I can assign this. So let me attach this. Let's attach this volume. Attach to an instance. So this is a controller node. Device name dev SDF. Now even if you add this, the name would be different. So go by the default and let's see what name we get. Okay. Now here again attach this one also. So instance dev SDG. Attach volume. All right. Now that's done. Both of them are attached. Let's go to EC2 dashboard, and this should be visible there as well. So let's click on running instances. Click on this. And if we go to storage now, we should be able to see 3 drives attached. All right. So now it's time to log in and let's see. So to list all those, I think the command is df-h, or so here I don't think we are able to see that. The command should be list block lsplk, and here I can see 20 GB and 20 GB. So these are the two blocks. So now what I have to do is I have to edit the env file that we just created. So let's so I'm already into runtime fabric. So vi env. What I have to do is edit this. Shift insert. Let me copy this. This is the name of that disk. So I'll copy this. Now let me edit this file. So etcd should be this one. Let's paste this. And for the second one, it should be, I think it's 2, right? Okay, 2 and 1. So let's change. So it should be 2, or instead I'll just copy to avoid making mistakes. This is okay. Let's just paste this. Okay, looks good. Uh, so that's it. We just have to change this at cd and docker escape wq. So it got saved. Let's check the file again. So it has the correct values. So now our configuration file is almost ready. Now what we need to do is get in the init file and just execute the script so that it installs. So let's do that. All right, so now let's move the init file. So we'll go to the manual folder inside the scripts folder. Take this file, just paste it here. Ensure that you give the required access. So this is I have logged in as an EC2 user. I need to give access to the root user. So let's give all. So you can also do 777 access. That should be fine. Click OK. So now the root user also should be able to access this and execute this file basically. So now before moving ahead, also ensure that you in the CNV file you enter the mule license key as well if you haven't added, and it's not mandatory to add at this point in time. You can also add it later on, but to avoid that hassle, just add it here. So I've already discussed how can you download the mule license and how to encode in base64 in the RTF EKS video. You can check there. Or else if you already have a license, this is how you encode it using Windows PowerShell. So I've already done that, and now it's time to run the init.sh script and see if it works or fails. Whatever happens, let's see. All right, so now everything is mounted. Let's list the file. So I do have the init.sh. Let's run this file, init.sh. Hit enter. So it has started deploying. So it's on step 2. It's thing looks like it's downloading some updates and patches. So we'll have to wait for some time and it should deploy everything at least for the controller node. Right now we haven't done anything for worker node. So now right now it's on step 10 where it's fetching the runtime fabric package from this URL, and it has done a couple of tasks. Let's see what all it has done. So it has checked the properties, installed the required packages, so then formatted and mounted the disks. So we assign two volumes, right? So it has formatted and then it has mounted all of those. So if you see this dev NVMe 1 and 1, it's visible. Then it's enabling and configuring kernel modules, IP table rules. So all those the lift and shift that's happening for installation is happening right now. It takes around 10, maybe 10 to 15 minutes to finish this installation. So right now I think it's downloading that file, and that file is around 1 gigs in size. So that's the reason it's taking some time. All right, so now the RTF deployment on the controller node is successful. You see, it says RTF installation complete. There were total 18 steps that were executed successfully. And if we go to the platform, we see it's in active state, and we can see controller is 1 nodes, worker is 0 nodes, and load balancer 0 nodes. So right now we just have the controller. So the vCPU and memory, everything is showing as 0 because we do not have any worker assigned. So we'll work on that. But that's how you install the controller node. And behind the scene, it created all the uh, containers and pods that we have discussed in the previous slide. So everything got created. Now, important thing that you would need here is the monitoring tool which comes with Gravity. Now, remember this thing is only available in the appliance model and not in the BYOK model. So this is the step number 12 that you should save it, because this will help you to access the ops center, this credentials. So let me just copy this and keep in handy. So we can use this credentials to access this console. The only thing that you would have to do right now is in the AWS console, allow external access to this 32009 port. Once that is done, you should be able to access the site. So this is how I've accessed. And now since the certificate it's self-signed, the browser complains that it's unsafe. But let's proceed. And once we proceed, it brings us to the web login. So we can use these credentials, admin at runtime fabric, and the password. This is the randomly generated password. Paste this, login, and we can see the console. So now you can check the server details, how many servers are there, perform operations. So whatever the operations were performed can be seen here. You can also check the logs. Basically, if you do not want to log into Putty, you can also try to check details from here. Go to admin, and I think in Kubernetes. So you can see the Kubernetes pods, services, jobs, daemon sets, deployments. All of this should appear based on the namespace you select. So see the RTF namespace. We see all the uh, pods running right now. And this is what we have already discussed in the previous videos, right? So all the services, pods, jobs. We'll discuss this in even more detail once the worker nodes are up, but just for an overview, that this is how you can uh, do or check everything, all the Kubernetes related configuration. You can basically monitor everything. So you can explore this. You can also add users to this by going to settings if you want to give access to others. So add roles, users, auth connectors. So there's lot of things available on this ops center. You can explore. Monitoring helps you to give an idea of the utilization. So it will create charts, and all of this is possible with the help of Gravity, which is being used behind the scene, and those help clear and everything. So that's helping us to give all this detailed information. So now that we have installed the controller node, it's time for us to install the worker node. Now, in order to deploy any application, we need to have at least two worker nodes. So let's work on installing the worker node. All right, so now let's create the worker node, which is the first worker node. And this time around, it should be quick because we have pretty much everything set up. So let me name this as VP RTF worker node. And I don't need this image, I need a specific image. So let me browse through those image which I need. Otherwise, instead, what we can do is let's open the AMI tab. So I've already selected. Let's choose this, launch an instance from the AMI. Now inside the name and tag, all I need to do is give the name. So VP RTF worker node hyphen A. So this is the first node. So we have decided to use R5. So let's choose R5 large. R5 dot large. Yeah, so this should be fine. 16 GB of memory. And Next, let's move to the key pair. So we select the existing one which we have used for the controller node. Security group, let's select existing. Let's edit this. First of all, make sure that you auto assign public IP set to enable. That has to be enabled. Then, so VPC is fine, that the one that we have. Subnet is also the one that we already created, same as the one that's used for the controller node. Next is, let's set this to 30 GB, and security group, let's select security group. This should be fine. And yeah, that's pretty much. And let's hit on launch an instance. So once that instance get launched, we have to log in through putty. Let's remove this filter. Okay, both instances are now okay. This is yet to status check is initializing. Let's try to open this. Copy this. Go to putty. New session. Paste this. Open. Accept. EC2-user. Okay, I have to select the auth mechanism again. So new session. Go to SSH. Expand. Auth. Browse. Send downloads. I already have this. Open. Then go to session. Paste the public IP address. Click on open. Login as EC2-user. Done. We are now logged in. Let's change it to root user. Okay. All right. Now the next target is to add the Docker device, right? So if we go to storage, right now we have only one disk drive, which is 30. Now let's add volumes to it. Let's go to volumes. So until now we have consumed 30 plus 30, and now again this is 30. So around 120 GB of storage. No, 30 and 40 and 30. So let's create one more volume. Let's make it as, now since this is a worker node, let's use it as 30 GB, or 30 GB should be fine. Let's not make it as 20 because this is worker. But before that, we need to ensure that we are in the same region. Otherwise, uh, I'll have to create it again. So let me go back to the instances. It should be in the 2C region, but let's just confirm it on AP South is 2C. So if I go back, GP2, AP Southeast 2C. All right, add a tag, VP worker node A, and let's create this volume. So for worker, as you know, we would need only one volume because we just need Docker. The control plane needs two volume because it needs Docker. It needs etcd as well. So while this is getting ready, okay, it's available. So now what we can do is we can quickly attach actions, attach volume, instances. So we have to attach to worker node, attach volume. Now the same thing, we have to log in via WinSCP. Let's create a new session, enter the IP address, advanced, select the file, username is EC2-user login. All right. So now again, I have to do the same thing that we have done in the controller node. So in this case, let's follow the same procedure, create those folders cd opt ls cd any. So we have to create mkdir and cd anypoint and then mkdir runtime fabric. Okay, now let me give the permission to the EC2 user chmod 777 to runtime fabric so that I can paste the file. All right, now let me quickly move to that folder, pt, Anypoint, then runtime fabric. All right, now so I've already created the files. So this is the env file. Make sure that this is not having an extension of text. It should be type file, otherwise it will create problem. Let me just edit and show you what are the contents. So basically this thing has given me the output. I've just pasted. I've just updated the IP address because at that point of time haven't updated yet. Let's update it. So the RTF private IP and the Docker device, these two things have to be updated. Installer IP remains the same because that is the leader IP, which is the controller IP. So that remains the same. The private IP for this worker node A, we have to give it. So let's check what is the private IP. So it's 67. So let's update that file, make it as 67, and observe that uh, the license, the activation token, nothing is required in this case. It's just a worker node with role of joiner. And same will be applicable if you are trying to add any new controller node. It will be controller node, but it will be a joiner, won't be a leader because leader is already there and it won't require any activation token as such now because that token is already being used. All right, so now, okay, what we have to do is update the Docker device. So we follow the same procedure that we have done. Use lsblk command, and this is the one that we have allocated. So I'll just replace this. All right. So looks good now. Now just copy this file to this location. All right. So I'll drag and drop and change the permissions, properties. Done. Now let me paste the script as well. Manual scripts. Okay. Right click, properties. Let's give execute access. Okay. So I have the env and init.sh file ready. All right. Now I'm back in the worker node. Let's initialize the script. So let's first list the directory. I'll cd into this and then run init.sh. So it has started. So the installation is almost about to complete. It's just that it's trying to join the cluster, meaning the controller node that's already created. And most of the steps are pretty much completed by now. And observe that this worker only has, I think, 12 steps, whereas the controller node was having 18 steps. So it's probably because the control plane components are not getting installed on the worker nodes. Now, while it's connecting to the existing cluster and it's in the process of installing RTF on the worker node, there would be some changes in the controller node. So let's observe. So we log into the controller node and there is a component called as gravity which takes care of everything. So let's type gravity status. And if you see the status, right now it's expanding because we have a worker node which is trying to uh, connect to this node. So the current state is expanding. When it completes, the state would restore back to active, and we should be able to see all the uh, nodes, that is the worker node and the master. Right now, we only see master node. So let's wait for the worker to get the setup done completely, and then let's observe what is the status. All right, so looks like this step is taking forever to complete. So possibly there's something wrong going on and we have to troubleshoot this. So if we check the active operation, which is operation expand, is on 0% complete from the last 7 minutes. So probably some network issue might have caused this to get stuck in the state and it's not even completing it. So what we would rather do is uh, let's first of all let's stop this and try to rerun. So Control C, clear. So my troubleshooting point would be that I'll try to rerun this. But before trying to rerun, let's do ls-a, and this is the state file which has all the state listed to it, right? So if we delete this, then it will start from the beginning. If we do not, then it will start from the point where it stopped. So first let's try with the point where it stopped. So let's try to run this. And it says runtime fabric installation complete. All right, so looks like it was able to complete all the step the moment I ended it. Now let's go back to gravity status. All right, so it took some time, but eventually it was able to move back to the active state. But it looks like, despite this is an active state, we see that the operation which was expand failed. It's showing as 54 seconds ago. It took 9 minutes and it eventually failed. So, and that's the reason we also do not see any worker node connected. So what we have to do is we have to execute it again. So uh, let's first clear this. Now what we have to do is remove the state file that has been created. So rmrf. So basically this is a folder which has all the details. So if I see there are a couple of files in it. So what I'll do is I'll just clear up this folder so that the installation happens again. So ls-a rmrf dot state. All right, it's cleared. Now let's try again. init.sh, and this time around hopefully it should work and connect to the controller node. It's need to connect. Now, one important thing from troubleshooting perspective, it might happen that sometimes this process might get stuck and not even proceed further. Even if you exit, uh, it might still get stuck. So what you can do is you can use gravity plan and check what is stuck. So right now it shows, right, some process was failed to initialize, which was this one, which has already finished off. But if there is some new one, you can always use this command and You can specifically set that this operation is complete so that it doesn't remain in the list of active operation, but explicitly comes to the list of completed operation. And the cluster state would go back to active instead of expanding. So right now it's still inactive because it's yet to connect. Let's check again. Let's go back to the worker node. Still trying to join. Let's see how long it takes. Okay, so finally we have the status in expanding, and uh, here we can see some activity going on as opposed to the previous one wherein it was stuck. So it turns out to be that the security group that I configured was modified by me only later point of time. So that is why it was failing. But just ensure that uh, inside your security group, at least from the CIDR block that we configured for VPC, you allow all the traffic. Even if you allow TCP, that should be fine, but you can consider allowing all traffic also, so that you can at least test the connectivity by uh, using the ping command. So this was the rule that got deleted and that caused the issue. Alternatively, you can make it all traffic uh, so that you can also execute ping command. Now, in this case, if it's all TCP, it won't be able you won't be able to ping the other server. But if you make it all traffic, then you can also ping. But all TCP also should be fine. But just in case if you encounter any other issue, you can basically do a ping and test the connectivity. For example, let's try out here. So right now ping won't work. 1111. See, the ping is not working, but this doesn't mean that the connectivity is not there. The connectivity is there. It's just that the rule that we have configured is for all TCP. So this rule is important. In my case, it was deleted accidentally, and that is why it started failing. But you can also consider having all traffic because it's just internal, right? So within your CIDR block, you can use any protocol. And now let's go back and see what's the status. Gravity status. All right. So we see that it's back to active and the master nodes and the worker nodes are all up and healthy. Let's go back to the worker node. So, all right. So everything is configured. All the 12 steps were executed. Success. Back in the platform, here we are able to see the controller as one and worker as one. However, now if I go to the associated environments to associate this runtime fabric to a particular environment, I'm not able to associate. That's because it's not supported for any workloads right now. The reason being, we need to have at least two workers, and we are now able to see memory as well. So this memory is of the worker node because all our apps will be deployed to the worker node and not the controller node. So the cores and memory represents that of a worker node. So now our task is to create one more worker, and then we'll be able to deploy application. So I'll not be going through through all the steps that are required to create a worker node, but the process is almost similar. It's the same that we have done for the first worker node. It's just that the IP address would change. So I have finally installed RTF on the second worker node as well. So now the topology looks like this: one controller node and two worker nodes. So this means that now I can deploy apps to the runtime fabric. Also, if we see the memory has increased now, it has become 29.9. So combined memory of the two workers and the cores are also combined of the two workers. Now, if I go to the associated environment, I see an option of selecting the sandbox. So let's select it. So the allocations have been applied to the sandbox environment. So any app that I want to deploy now to the RTF instance that I created, I can deploy it from the sandbox environment. Now, one important point that I would like to point out here is that I eventually ended up using T3 X large instance for the worker node. The reason why I had to choose this option is that with the R5 large that we chose previously, the installation was failing in the IP tables step, which I am still not sure why it was failing. But when I tried with the T3X large version, it works successfully. So, in case if you try out with an R5 large instance only for worker, then in that case, you can consider using T3X large and then it should be working fine. That's just one observation. So consider using T3X large instead of R5 large for the worker node. All right. So with this, we have completed the RTF installation of the appliance model, and I hope you found the video useful. Thanks for watching.